Hello everyone, let's study Chemistry Class 10th, first chapter, Chemical Reactions and Equations. So I'll be doing this whole chapter in three parts, that is part 1, part 2 and part 3. In part 1, we shall study chemical equations, where we'll discuss how to write the balanced chemical equations. In part 2, we shall study types of chemical reactions, and in part 3, we shall study effects of oxidation reactions in everyday life. So chemical reaction. What is a chemical reaction? A chemical reaction is a process in which the original substances lose their identity and the new substances are formed with different properties. And these chemical reactions are irreversible, and these changes are also permanent in nature. You have already studied this in your earlier classes. Next, let's see a few examples for these chemical reactions. So first one is the burning of magnesium in air to form magnesium oxide. So when the magnesium burns in air, it produces white dazzling flame. It burns with the white dazzling flame. In the image here, you can see here that the magnesium ribbon is burnt on Bunsen burner. Then the magnesium oxide is formed. The next thing is the rusting of iron. This is also an example for a chemical reaction, and it's burning of fuels. Next, chemical reaction. So whenever a chemical reaction happens, what are the few characteristic features which you can see, from which you can or observe, from which you can see that conclude that the chemical reaction has taken place. So first thing is the change in color. The color of the reaction changes. Next thing is a change in state, the physical state of the substance, the reactant changes. Evolution of a gas, for example, when zinc reacts with sulfuric acid, in that case, it results in the formation of zinc sulfate along with the release of hydrogen gas. So next thing is the formation of precipitate. So what is precipitate? Precipitate is an insoluble solid particles. Insoluble solids. Next, change in temperature. These are the few observations from which you can see that the chemical reaction has taken place. Next, chemical equation. Chemical equation is nothing but representation of a chemical reaction. It is the representation of a chemical reaction. Let us consider an example. Magnesium reacts with oxygen to form magnesium oxide. So instead of writing this whole sentence, I can just write it in this form, where on the reactant side we use plus symbol, and also on the product side, if you get more than two products, then we just write them using plus symbol. So whatever you write on the LHS part, that is on the left hand side, it refers to the reactants, and on your right hand side we write the products. So such type of equation is referred to as the word equation. Now we can even represent the equation in even smaller than this. Means we can represent in a smaller way than this. That is by using the symbol, that is magnesium reacts with oxygen to form magnesium oxide. So reactants are the substances which take part in a chemical reaction, while products are the substances which are produced as a result of a chemical reaction. So next is balanced chemical equation. So what are balanced chemical equations? It's an equation in which the number of atoms of each element is same on both the side of the equation. So what is the necessity for us to write the balanced chemical equation? It is because it needs to satisfy the law of conservation of mass. Now what does the law of conservation of mass say? The law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. That is, the total mass of the reactants must be equal to the total mass of the products. So let's see the previous example. So here if you can see this example, so if you consider this example, see here you just have one atom of magnesium On the reactant side, on the product side also you have one atom of magnesium. But in case of oxygen, you have two atoms of oxygen on the reactant side, while on the product side you just have one atom of oxygen. So here oxygen is not balanced. So such an equation is referred to as unbalanced equation. So these equations are unbalanced. And these unbalanced equations are given a special name, that is skeletal equations. Skeletal equations. Now, how to write the balanced equation? So for that, we need to know how to balance the equation. So let's study that. So magnesium reacts with oxygen to form magnesium oxide. So in order to balance, first write down all the elements which is present in the reaction. So here we have magnesium and oxygen. So now below the reactants, you need to write how many number of atoms of each element is present in the reactant of that particular element. So magnesium, I have one atom, and oxygen, two atoms. On the product side, I have just one atom of magnesium and one atom of oxygen. So here magnesium is balanced, so you need not worry about magnesium, but oxygen is not balanced. So here in order to balance, I can make 2 on both the sides. So what I'll do for that, I'll multiply the product side by 2. So here this gets multiplied by 2. But now the number of magnesium on the product side changes to 2. So in order to balance the now oxygen is balanced, but your magnesium is not balanced. So in order to balance magnesium, I'll multiply the number of magnesium on the reactant side by 2. So now if you observe, the magnesium is also balanced and even your oxygen is balanced. So now this is your balanced equation. This is your balanced chemical equation. Now let's solve one more question, similar question. So zinc reacts with sulfuric acid. Formula of sulfuric acid is H2SO4 to form zinc sulfate. So now how to write this formula? Zinc sulfate. So in order to write the formula, let's study one method, that is crossing over the charges method. So where you will be writing the first the cation and next you will be writing the anion part of the compound. So in this case, zinc is the cation and sulfate is the anion. Then you will write its cationic valency and anionic valency. So zinc has got the cationic valency of +2 and and sulfate has got the anionic valency of -2. You will cross over the charges and along with zinc you will write the magnitude of the next charge. Means you will be just writing the magnitude, you will not write the sign. So it is Zn2 and SO4. The opposite side also you have 2. So now if possible you can simplify this. So here I can just write it as ZnSO4. If it is same, you can just simplify it and write it as zinc sulfate ZnSO4 plus H2. Now start balancing the equation. The same method can be applied here. Zinc, I'll be first writing out all the elements of the particular reaction. Then number here, zinc is 1, hydrogen is 2, sulfur is 1 and oxygen is 4. And on the product side, zinc is 1, sulfur is also 1, hydrogen is 2, oxygen is 4. Now if you observe, all the elements are balanced. So the equation that is given to you is itself balanced. Now let's move on to the next question. So what is a balanced chemical equation? I've already given to you the definition, that is the equation on which the number of atoms of each element is same on both the sides of the equation. Now why should we balance it? What is a necessity in order to satisfy the law of conservation of mass? So in order to satisfy this law, we need to balance a particular equation. So detailed answer is given to you here. You can refer to this answer. Next, let's solve some more questions on balancing. So yes, you can balance by the same method. First you will list down all the elements, iron, hydrogen and oxygen. And then you will write the number on the reactant side and on the product side also. Okay, now we need to balance Here hydrogen is balanced. So first you can go for iron or oxygen, whichever you want. I'll start with oxygen. So in order to balance, I will have to multiply the reactant side by 3. So if I multiply this by 3, then the number of hydrogen will now change to 6. 3 into 2, it will change to 6. And on the product side, now oxygen is balanced. Now your hydrogen is not balanced. So now on the product I'll try to balance the hydrogen. So for that I'll have to multiply this by 3. So I'll multiply this by 3. So it is 6. Okay. Now iron is not balanced on the reactant side. So on the reactant side I'll multiply it by 2. Okay. So now it is 2. Okay, fine. So now if you observe, your iron is also balanced, hydrogen is also balanced, and oxygen is also balanced. So this is your balanced equation. Now let's move on to the next problem. Similar question. First we'll list down the elements, then the number of atoms on the reactant side, product side. Here hydrogen is balanced, oxygen is not balanced. For that, on the product side I'll multiply this by 2. So if I multiply by 2, the number of hydrogen on the product side changes to 4. So for that, on the reactant side, I'll multiply the number of hydrogen by 2 so that it becomes 4. Now if you observe, on the reactant side it is, totally hydrogen is balanced here, and even the oxygen is also balanced. So this is your balanced equation. Now let's move on to the next problem. So hydrogen reacts with chlorine to form hydrogen chloride. So hydrogen always exists in the diatomic form, that is H2, reacts with chlorine, which always exists in the diatomic form, that is Cl2, to form HCl, hydrogen. Now let's balance the reaction. So you can directly balance this. So on the reactant side you have 2 hydrogen and 2 chlorine. So on the product side, if you just multiply it by 2, now the whole equation is balanced. So if possible, you can do it directly. If you find it difficult, then you can write it in detail. Now here you have to find out the formula of each compound. Then you can go for balancing the equation. So first let's find the formula. So barium and chlorine. So always these halogens like iodides, fluorides, bromides, all of them have the anionic valency of -1. Now barium plus 2. Cationic valence is +2. Now cross the charges, it becomes BaCl2. So 1 need not be written. Similarly, aluminium sulfate. Al, its cationic valency is +3, and for sulfate, the anionic valence is -2. Again, let's cross over the charges. It becomes Al2SO4 thrice. Now barium sulfate. Here I have barium with the cationic valency of +2 and sulfate with the anionic valency of -2. If I cross the charges, it becomes BaSO4. Next, aluminium chloride. Aluminium has got a cationic valency of +3 and chloride anionic valence is -1. So if I cross the charges, it becomes AlCl3. Now this equation becomes BaCl2 plus Al2SO4 thrice gives barium sulfate BaSO4 plus aluminum chloride AlCl3. Now let's start balancing. So you can go by the method, that is writing all the elements and writing the number of atoms on the reactant side and on the product side, or you can go by direct method. So first, if I check the number of atoms of aluminum on the reactant side, I have 2. So on the product side, I'll just multiply here by 2. So now the number of aluminum is balanced. So the number of chlorine on the product side, it is 6. 2 into 3, it is 6. So on the product side, it is just 2. So I'll multiply this by 3. Now if you check the barium, the number of atoms of barium is 3. So on the reactant side, it is 1. So I'll multiply this by 3. So now you can find, I guess my equation is balanced, so that we confirm. So on barium it is 3 and 3, sulfur is 3, and here on the product also it's 3. Oxygen on the reactant side is 12, and then the product side is 3 to 4, 12. Aluminium on the reactant side is 2, and on the product side also it is 2. And chlorine is 6 on both sides. So this is the balanced equation. Now let's move on to the next problem. Sodium reacts with, sodium is monoatomic, so it's just Na. Reacts with water is H2O to form sodium hydroxide. Sodium hydroxide formula is NaOH plus hydrogen gas diatomic H2. So here sodium is balanced, oxygen is also balanced, but hydrogen is not balanced. So for that, I'll just multiply the sodium hydroxide by 2. So that the number of atoms of hydrogen is 4. So on the reactant side, I'll multiply the number of molecules of water by 2. So number of hydrogen is 4, oxygen is 2. Here also oxygen is 2, sodium is 2. So for that, sodium also needs to be multiplied by 2. So this is the balanced form. So if you are finding this bit difficult, then you can go by the detailed method. Next problem. So yes, now it is given to you in the whole reaction is given to you in the statement form. It is given to you. So first we will have to write the chemical formula. First let's do that. Barium chloride. So for this you need to find out. Try solving this by your own, and the answer is BaCl2 by crossing over the charges method. Sodium sulfate is Na2SO4. Try solving this by your own. To give insoluble barium sulfate means it is in the formation of a precipitate. That is what it is saying by mentioning that it's insoluble. So barium sulfate is BaSO4 and solution of sodium chloride. In water, in the sense here, solution of barium chloride and sodium sulfate in water, in the sense it is in the aqueous form. Okay, so now let's try balancing the equation. BaCl2 reacts with Na2SO4 to give barium sulfate and sodium chloride. Sodium chloride. Now let's start balancing. So if you observe here, the number of sodium atoms on the reactant side is 2, but on the product side is 1. So what will I do? So I'll multiply the product side by 2. Now the number of chlorine is balanced, sodium is balanced, barium is also, so this is the balanced form. You can just check, barium is 1 and 1, so it is proper. Sulfur is also 1 and 1, oxygen is 4 and 4, and sodium is 2 and 2, chlorine is also 2 and 2. So this is the balanced form. This is the balanced form of the particular equation. Now let's move on to the next question. Sodium hydroxide solution. So sodium hydroxide, again, try solving this by your own. Sodium hydroxide formula is NaOH. In water, in the sense, they just mean that aqueous form. Reacts with hydrochloric acid, formula is HCl. In water means in the aqueous form. To give sodium chloride, NaCl. And water, H2O. Now let's write down the equation. Sodium hydroxide reacts with hydrochloric acid to form sodium chloride plus water. So now if you observe here, the number of hydrogen on the reactant side is 1, but on the product side it is 2. So I'll multiply by 2 on the reactant side. Now the number of chlorine is 2, but on the product side it is 1. So I'll multiply here by 2. Now if you observe, the number of sodium is 2 on the product side, but it is 1 on the reactant side. So on the reactant side I'll multiply sodium hydroxide by 2. Now I think my equation is balanced, so let me confirm. No, it is not yet balanced, I guess. See, sodium is 2 and 2. Oxygen is 2 and okay. So here I need to multiply by 2. So if you see on all the sides I have multiplied by 2, means I can cancel all of them. I can cancel all of them. That means the equation that was given to me initially was itself balanced. I simply balanced it. It was actually in the balanced form only. There was no necessity for me to change anything. Okay, so this is the balanced form. So every time first check, okay, whether the given equation is balanced or not. So this itself is a balanced form. Now next question, okay. HNO3, nitric acid reacts with calcium hydroxide to form calcium nitrate and water. So now start balancing the equation. So if you see here, the nitrate molecule is 2 in number, but on the reactant side it is just 1 in number. So for that, I'll just multiply this by 2. So the nitrate is balanced, hydrogen is also balanced, calcium is also balanced, but your hydroxide is not balanced. OH twice. Okay. So I guess it's better to solve this in the long format. Calcium, oxygen, hydrogen, nitrogen. Okay. So on the reactant side, I have one molecule of calcium, one atom of calcium. I erase this. I'll be solving this one first. Okay. And nitrogen is 1. But oxygen is 3 plus 2, 5. Hydrogen is 1 plus 2, 3. And on the product side, calcium is again 1. Nitrogen is 2. And oxygen is 3 to 6 plus 1, 5. And hydrogen is 2. So I'll start with nitrogen first. So in order to balance nitrogen on the reactant side, I'll multiply by 2. So then in that case, oxygen, number of oxygen changes to 6 plus 2, 8. And number of hydrogen changes to 2 plus 2, 4. And on the product side, first I'll go for balancing. Now nitrogen and calcium is balanced. Oxygen and hydrogen is not balanced. I'll go for balancing hydrogen. So for that, I'll have to multiply the number of hydrogen by 2. Okay, let me do that. So if I multiply this by 2, the number of hydrogen changes to 4, but the number of oxygen changes to 3 to 6 plus 2, 8. Okay. So now if you observe calcium, oxygen, hydrogen, nitrogen, all of them are balanced. So this is the balanced form of the particular equation. Now the next question. Sodium hydroxide reacts with sulfuric acid to form sodium sulfate and water. Now if you observe here, the number of sodium atom is 2 on the product and on the reactant it's 1. So I'll multiply this by 2 here. Now the number of oxygen atom on the reactant side, it is 2 plus 4, 8. And on the product side, it is 4, 2 plus 4 is 6. And on the product side, it is just 5. So for that, I'll multiply the number of molecules of water by 2. So oxygen is also balanced. Now hydrogen is 2 plus 2, 4. Yes, it is. This equation is balanced. If you are unable to understand this or if you are finding it difficult, you can go by the detailed method. So let's move on to the next question. Now zinc reacts with silver nitrate. So the formula of silver nitrate is AgNO3. So I'll try solving this by the crossing over the charges method. Next, zinc nitrate is ZnNO3 twice. Okay. So this is the equation that's given to you. Zinc reacts with silver nitrate to give zinc nitrate plus silver. So if you try solving this, so this is the balanced form. Nitrate, if I multiply 2, nitrate is balanced but silver is not balanced. So here I multiply by 2. Now the silver is also balanced. Next thing is potassium bromide reacts with barium iodide to give potassium iodide plus barium bromide. So same thing, first you need to write the formula. So potassium cationic valence is +1, bromide cationic valence is -1. So then the formula becomes KBr. Barium iodide formula becomes BaI2. And potassium iodide formula is Ki and barium bromide formula is BaBa2. Br2. Okay, so if you write this reaction, it is KBr plus barium iodide reacts to give potassium iodide plus BaBr2. Now here, the number of bromine atoms is not balanced. On the reactant side it is 1, on the product side it is 2. So for that, on the reactant side I'll multiply by 2. Now the number of potassium is 2 on the reactant side, but on the product side it is 1. So on the product side I'll multiply this by 2. Now iodine, okay, now everything is balanced. So this is the balanced form of this particular question. Now let's move on to the next problem. Hydrogen reacts with chlorine to form hydrogen chloride. I guess we have already solved. I guess this is already solved, or else try solving this on yourself. Next question is zinc carbonate. So carbonate has got the anionic valency of -2 and zinc has got the cationic valency of +2. So if I cross over the charges, it becomes Zn2CO3 twice, and I've told you already you can simplify this so that you will get ZnCO3. Zinc oxide, again the same thing, cationic valency +2, anionic valency is -2. If you cross over the charges and simplify, you will get zinc oxide as ZnO. Now carbon dioxide formula, you already know it is CO2. So now this equation becomes zinc carbonate decomposes to give zinc oxide plus carbon dioxide. So if you see, this equation is already balanced. Number of oxygen is 3 and here also 1 plus 2 is 3. Carbon is 1 and 1 and zinc is also 1 and 1. So this equation is itself balanced. Now let's move on to the next question. Magnesium reacts with hydrochloric acid to give magnesium chloride and hydrogen. So here I guess only magnesium chloride formula needs to be derived. So magnesium cationic valency is +2, chlorine anionic valence is -1. So if you cross over the charges, it becomes MgCl2. So this equation becomes magnesium reacts with HCl hydrogen chloride to form magnesium chloride MgCl2 plus hydrogen gas H2. So here if you observe, hydrogen is not balanced, so I'll multiply this by 2. Chlorine on the reactant side is 2, on the product side also it is 2. So now magnesium is 1 and 1. So yes, this reaction is balanced. Now let's move on to the next question. Aluminium is monoatomic, reacts with copper chloride. I guess it needs to be derived. Copper has got variable oxidation state, and here we'll be considering its cationic valency as +2. Fluorine is -1. So if you cross over the charges, the formula becomes CuCl2. So aluminum reacts with CuCl2 to form aluminium chloride. So aluminium cationic valency is +3 and chlorine anionic valency is -1. So if you cross over the charges, then the equation formula becomes AlCl3 plus copper is Cu. Now start balancing the equation. So if you observe here, the number of chlorine atoms on the reactant side is 2 and on the product side is 3. So in order to balance this, on the reactant side I'll multiply by 3 so that the total number of atoms of chlorine becomes 6. And on the product side I'll multiply by 2. So the number of chlorine atoms will also become 6. Now aluminium is 2 on product side. So on the reactant side I'll multiply the number of aluminium by 2. And if you observe copper on reactant side it is 3. On the product side also I'll make it 3. So this is the balanced form of this particular equation. Now let's move on to the next question. Barium chloride reacts with potassium sulfate to form barium sulfate and potassium chloride. So this is a homework. Try solving this by yourself. Next question. Sodium chloride reacts with silver nitrate to form silver chloride and sodium nitrate. So here if you observe, the number of sodium atom is same on both the side. Nitrogen is also same on both the side. Oxygen is also yes balanced. Silver is also balanced. Chlorine is also balanced. So this equation is itself in the balanced form. Now let's move on to the next topic. That is classification of the chemical reaction based on the energy. That is, if the energy is absorbed or if the energy is released, we classify the chemical reaction into two types. That is, if the chemical reaction involves the release of heat energy or any sort of energy, we refer to that as exothermic reaction. And if the chemical reaction involves the absorption of energy, if the energy is absorbed, then we refer to those reactions as endothermic reactions. So let's consider a few examples. For example, when calcium oxide reacts with water to form calcium hydroxide, releasing a large amount of heat. Releasing large amount of heat. So if you observe here, the energy is released. So that is why we refer to it as exothermic reaction. So calcium oxide, the common name is quicklime. And calcium hydroxide, its common name is slaked lime. Now similarly for endothermic reaction, the calcium carbonate, okay, when it is heated, it decomposes to give you calcium oxide and carbon dioxide. So if you observe here, the energy is basically absorbed here. So such type of reactions are referred to as endothermic reaction. Now again, the common name of calcium carbonate is limestone. This is all for your information, knowledge purpose. And calcium oxide is quicklime. I've already given to you. And there are some other examples which you can observe in your day-to-day situations, like exothermic reaction test, the decomposition of animal matter or decomposition of organic waste, okay, or vegetables, decomposition of organic waste, I'll say. Large amount of heat is evolved. And even respiration process is also example for exothermic reaction. Even respiration. What is the reason behind this? Why respiration is considered as an exothermic reaction? So during digestion, large molecules of food is broken down into glucose. Okay, and the oxidation of these glucose takes place when you respirate. That is when you breathe, the oxidation of glucose happen, and during this oxidation of glucose, large amount of heat energy is released. So during oxidation of glucose, which happens during respiration, large amount of heat energy is released. So that is why we refer to this respiration as an exothermic reaction. Large amount of heat energy is released. So you can also write down the chemical reaction that happens in the body during respiration. That is C6H12O6, which is nothing but your glucose, oxidizes in the presence of oxygen to form carbon dioxide, hydrogen gas, water, plus large amount of heat. So this is why we consider respiration as an exothermic process. The detailed answer is given to you here. So thank you. So in the next video, we'll be discussing on the types of chemical reactions. Please do like, share and subscribe. Thank you.